Let us look at the chem. Today's lesson is based on the low key known as chem. Now let us read the information given to us. A plate chem rotates in an anti-clockwise direction. It's important that we note this. It's rotating in an anti-clockwise direction and at a constant velocity, imparting the following motion to a wedge-ended follower. A wedge-ended follower is this area here. This is known as our wedge-ended. There's another one which is known as a roller, but this one here is known as a wedge-ended. All right. It goes on and say, which reciprocate along a vertical center line that passes through the center of the camshaft, as shown in figure below. The motion of the follower over the first 90, the follower rises by 35 with uniform motion. That's a straight line. The follower is then at rest for 30 degrees. The follower then rises with a uniform motion. Again, that is a straight line to a total height of 60 millimeters over the next 60 degrees. The follower then returns to its original position with a simple harmonic. Now this changes, so there's a different way of doing that. Now we need to understand and read what is our scale for our displacement graph. Now the displacement graph with the horizontal scale of 6 millimeters equals to 30 degrees. That's what's important. And vertical scale of 1:1. The camshaft, the cam follower and the follower, that's what we are given. This is your camshaft, diameter 20. The 26 distance is known as your minimum distance. And then what we'll then do is we're going to do all the drawings, add to the drawing all the labels and the direction of rotation of the cam. Now we need to deal with 6 millimeter equals to 30 degrees. So we're going to draw the displacement graph in this position here. So we're going to have starting from 0 degrees. So we need to draw that. Now you have drawn these lines, vertical lines, which we said 6 millimeters equals to 30 degrees. Now you need to go back to your information as to what is happening. All right, so let's go and read. So it then says, over the first 90 degrees, the floor rises by 35. So it means at 90 degrees, I must have a rise of 35. So let's quickly do it like this and say it's going to rise by 35 at 90 degrees. So I'm going to draw from 0 to 90. This is your 35, right? Then it says, the next plate says, the flower is then at rest for 30 degrees. Now the rest for 30 degrees is from 90 to 120. And then it goes and say, the follower rises with a uniform motion to a total height of 60 millimeters over the next 60. So 60 is our total at 60 degrees. So now let's just check. So 60 is our total first. Let's do the 60. 60 is our total. 60 is our total. So that's what you're going to do. That's our 60, because from there to the 60, we said it moved, is at rest for 30 degrees. Over the next 60, which is 30, 60, the follower is then at a total height of 60. So that is 30 and that's 60. So we go here. So let us draw the line which says at rest. There we go. All right. Now that we have that, let's read. The next one says, the follower returns to its original position with a simple harmonic. Simple harmonic, we need to draw a semicircle. Right. the semicircle which I've drawn, because they say it returns from height of 60, it goes back to its original position, which is going back to 360 on the horizontal line. So this here semicircle means it must be 60 millimeters. So half of the semicircle is 30. So what I did was, all you do is half of 60, which is this height here, is 30. Then you draw your semicircle. Then this semicircle must be divided into 6 equal parts using a 30 degrees square and a 60 degrees square. So let us do that. Now there's your semicircle, which has been divided into six equal parts. It then means this division goes here, that's one. Next division, it goes next line. Next division, which is already there, then this one goes here, and you are left with just one, and that goes here. But then let us match these properties, so the lines, so that they look the same. So that's construction line, construction line, construction line, construction line. So now all you have to do now, you need to join this freehand. So joining it freehand means from that point to that point to that point, coming here, that point, that point, and finally that's where you are. So this is your displacement graph completed. All you have to do now is to put the label there. Now that your label is there, it means everything that you need here is complete. So now we have the center line, the position of the center line. That's where I'm gonna have my follower. That's where I'm going to draw everything using these coming to that side. So this is my follower, I'm gonna draw it there. So let me take this. It says height of 63. This is 8 using the center line. Here we use a 60 degrees set square, a 60 degrees set square, right? And then our minimum distance, we said, is how much? Is 26. And the diameter of the camshaft is 20. So we're going to draw these, right? So now there's my follower using this information given to me. 8, 63. There's it drawn there, right? Then my camshaft. Now the next step is to divide the camshaft into 12 equal parts using a set square of 30 degrees and 60 degrees. So I'm going to divide these. All right. Now there's your camshaft, which has been divided into 12 equal parts. Now we need to read the direction. Remember we said a blade cam rotates in an anti-clockwise direction. If it rotates in an anti-clockwise direction, then your labels go clockwise. So in other words, what is given here, you label or your numbering goes in an opposite direction of what you are told. The rotation is anti-clockwise, so your numbering must be clockwise. Let us do the numbering. So firstly, the top is your 0. So in a clockwise direction, that should be 30, 60, 90, going all around. So let's put that label. Now that all your divisions has been labeled all over, let's see, we have all of them. Yes, we do have. We said we go in a clockwise direction because our information is saying that it must go in an anti-clockwise direction. So with that said, it means I must show my direction here as showing as anti-clockwise direction. So because I'm going to get marks for that. Now the next thing that I need to do is I need to project all these points here, this to the vertical line using my T-square. So I'm going to project all these lines from 0, 30, 60, 90. I'm going to take all these lines into my vertical lines. Then from there, I'll then use a compass to take them to their respective degrees. So now we have all these lines going to the respective vertical line. You'll notice that the blue lines are the ones for our linear motion. The blue lines are all one for linear motion. And our simple harmonic is these lines here, 1, 2, 3, 4, 5. Those are the lines for our linear motion. Together with this here it's bit of both. It's your simple harmonic as well as your linear motion. But I will then take you through each one to now you place your compass. Simply place your compass at the center here. Let's see if you place your compass here. 0 is already there, fine. Then we have to move this 0, rather 30, it must go and cut at 30 degrees. Right, so you're going to do that together. Can we just move this up so that it's in a correct place? Now, if you realize, I used 30 degrees, place my compass here at the center, then open it to 30 degrees line, then swing it goes to 30. So that's my first point. So I need to repeat this 60, it goes up to 180. I'm going to be repeating the same thing. Move the line onto 60, move the line onto 90, move the line up to 150, move the line to 120, move the line up to 180 degrees. So I'm going to be repeating the same thing. Now we have all the points that we need. Notice the blue lines. That's 0, that's 30, that's 60, and it goes to 90. Why 90 continues like this? You see, when it's at rest, we don't use freehand. We use a compass to join the 2 points. From there to there, we don't need freehand, so that will be actually a compass. From 120 to 150, it then rises from 150 to 180. So we need to draw this freehand. 0 goes to 30, there's 60, 60 it goes to 90. Stop at 90 with freehand. We said this becomes a compass. Then the next one is from 120 to 150 to 180. So this is where we use freehand. So we have half now. All right, so now we need to bring these lines on the other side. All right, so now that we know the method that we place our compass at the center, then we scribe an arc on each division, place our compass at the center, place your compass at the center of the camshaft, you open it to the relevant division, then swing and scribe an arc on 60 because this was a 60-degree line. Then you continue like that until you complete all of them. So this is your first half now drawn dark, part of your cam profile. There's this part here, we said we used a compass. That's why this one here, if you look at it, it's not freehand. Then now, like I said, I'm going to take these points and do the same thing. And let's start with the first one here, which is this one here would have been 330. So 330, I'm going to make this example 330. So this 330 goes to this 330. So basically, so it must stop here. All right. So let us move this so that we know exactly where it stops. The 330, it stops here. So I'm going to keep on repeating the same thing until I have all the divisions where it's cutting. Right. So there's all my divisions. First one 330, next one 300, next one 270, next one 240, next one 210, then it goes back to 180. So all I need to do now is to draw or join these. From 180 goes to 210, 240, 270, 300, 330, then it goes back to its original position, which is 360. So we need to fix this. Now that is fixed, so this is your complete cam profile, and that's how it's done. All right, so thank you for watching.